Hello everyone, this is Sharath. I'm a data scientist working at IBM India Software Labs. Today I'm here to cover about machine learning and NLP and how it will fit into building AI solutions. I think most of the content or some of the content regarding ML deep learning is covered already by the previous speakers, but I'll still go ahead and cover it quickly in the interest of time. So when we think of AI, right, as it was called out earlier, it is a system which will mimic human characteristics, right, which means a system which can, do problem solving, which can understand natural language, which can reason, and which can, understand sounds and all that, right? That can be called a system which is having AI capabilities. In AI, there are two types, right? One is generic AI and another is narrow AI. Generic AI is pretty much having all the characteristics of humans, right? As it was mentioned earlier. Whereas narrow AI is specific to certain tasks, right? For example, a system which is very good in identifying handwriting or identifying images, right, and cannot do anything else is a classic example of narrow AI. And ML or machine learning is a subset of AI, or we can say that ML is one way of achieving AI, right? We can also say that all machine learning is AI, but not all AI is machine learning, right? For example, a chatbot built using complex rules and decision trees is definitely artificial intelligence, but not machine learning. Whereas a chatbot built using ML capabilities, right, for example, learning new terms and try to improvise the response from the chatbot, called as an ML system, which is aiding into an AI solution, right? And deep learning is again a subset of machine learning, where we try to mimic the human brain by interconnecting the neurons and trying to understand what the knowledge that it is carrying forward, right? And that is how we will be able to build deep learning solutions. There are, of course, different types of deep learning algorithms, right? Like artificial neural network, convolution neural network, generative adversarial networks, right? Which are used for generating images and so on and so forth. So in a typical data science, what exactly is data science, right? It is all about unlocking real value from our data, right? It is a multidisciplinary blend involving statistical research, computer science, data processing, domain expertise, right? Which is very important, which was discussed a few minutes back. And of course, mathematics, right? Mathematics is needed to understand how each algorithm functions at the back end, and which algorithm might be best fit for a particular data set, right? And the model building steps is pretty much same, be it machine learning or deep learning techniques, right? First, we need to define the objective. We need to kind of source the data, right? And it also curating the data and all those stuffs, which is included in step 2. And then we go ahead and build the algorithm using different methods, right? And then we create an experiment, and then we try to implement and see how the results are functioning, right? And then we go back to defining the objective. So it is more or less an iterative process until the desired result is achieved, right? So each step has a lot of importance and is to be done diligently to achieve complete success. So when it comes to machine learning, there are multiple types, right? Supervised learning, unsupervised, and reinforcement learning. Supervised learning is where we have the target variable included in the data set itself, right? For example, there are two types of supervised learning. One is regression, another is classification. Regression is where we try to predict a continuous variable as target, right? Continuous variable means the values can be between 0 and infinity. For example, you want to predict the salary of an employee given his skills and experience, number of years of experience, and location, right? That could be one example of regression. It can be weather forecasting, sales forecasting, so on and so forth. Classification can be binary classification, where the output would be yes or no, whether an event will happen or not, right? It can be used in so many things, right? Like customer retention, fraud prevention, right? Image classification also, and so many other things. There is also multi-class classification, where the response could be more than 2, right? That can be used pretty much probably in images, right? Given an image, you need to identify which animal would that be, right? There can be multiple classes which might fall into the classification criteria. And in unsupervised, right, the target variable is not evident in the dataset. And what that means is we want the data to tell us a story. And one good example would be to cluster the data to make groups within the dataset. For example, customers having similar buying behavior can be grouped into one cluster, and so on and so forth. And that can be used for target marketing, customer segmentation, and so on and so forth. Dimensionality reduction again is to reduce the number of dimensions. If we have like hundreds of thousands of dimensions, then how do we reduce that without having an impact on the outcome, right? That caters to dimensionality reduction. Reinforcement learning is pretty much involved into games, right? It talks about step-by-step learning. For example, if we try to teach a robot to climb the stairs, right, the robot might not succeed in the first go, but after repeated attempts, it might succeed. So, right, so that can be categorized into reinforcement learning, where for each correct step there is a reward given, right, and the system will make use of those learnings and will be able to finally achieve the objective. So some of the common use cases for data science, right? It is typically there. It was there in the past as well, and it continues to be there because of the value it adds, to the particular segment, right? In retail, we have market basket analysis, price optimization, right? Warranty analytic, customer sentiment analysis, and so on and so forth. And also in BFSI, we have like fraud detection, risk mitigation. We also have like customer lifetime value prediction, and so on and so forth, right? And for AI, self-driving cars is always there. Probably it tops the list in almost everybody's mind, right? When we think of autonomous AI system. And there are also a couple of other use cases, right, which talks about creating a chatbot, right? Mining the data using neural networks, and automatic transcription, and so on and so forth. So this is at a high level. This is the difference between humans and cognitive system, right? Cognitive system definitely excels in some areas, like for example, pattern identification. Right? If there are like hundreds of thousands of rows of data, and if we are given that data set to analyze the pattern, it is pretty much impossible for us to come up with that insights, right? Whereas the machine can do it pretty quickly. And also eliminating bias to a great extent is achieved in the cognitive system. And it can do ML and natural language processing at scale, right? But the imagination and all the other aspects which humans excel at, right, that is still some time away for the cognitive system to kind of achieve that. For example, recently rolled out language model GPT-3, right, from OpenAI, which has 175 billion parameters. Despite having such a huge parameters list and pretty much trained on the entire Wikipedia, it is stated as having an accuracy level of only 55% when it comes to natural language processing, right? That is how tough the NLP can be, and it is still some time away for cognitive system to kind of achieve great accuracy in that aspect, right? So cognitive system definitely, it will try to reason and understand, right? And it will also learn and interact and probably learn new things and try to factor that into its repository to churn out great responses. For example, a humanoid bot, right? You try to teach conversations, and the more it converses with humans, the more it gets to learn, and then it will improvise its response, right? And then it will be able to add a lot of value, be it as at help desk or at customer support or as a sales agent, right? There can be so many cases where the cognitive system can excel. And some of the common use cases for NLP, which I think of would be, the list here. Chatbot is definitely there. I mean, we interact with so many financial institutions and all that, right? The first thing that we are greeted with is chatbot. Sentiment analysis, as we called out, because any product company, right, would want to know how the product is faring in that market. to try and understand the sentiments and to kind of make improvements if needed. Text summarization, topic modeling, these are very helpful when it comes to summarizing news articles quickly, right? For example, if we do not have time to read the entire article, we can just go with the summarized article and identify the keywords and get a gist of what that article is about, right? That way we will not miss out on that article. It can be applied to other activities like, summarizing minutes of meeting, right? And also topic modeling. If there are like thousands of documents and we want to understand which document is talking about, say, football or automobiles, right? Then this topic modeling will be a great help where it will be able to kind of analyze each and every document, call out different topics, and then we will be able to kind of index into the document of our requirement pretty quickly. Right? Spam classification and image captioning also are some of the use cases for NLP. Image captioning, again, it is a very complex thing because different images or the interpretation, right, might be pretty different for different people, right? We need to make sure that we are eliminating the bias from that reasoning, and then we should come up with the image captioning. Some of the use cases which ML and NLP together, right? I feel that in hiring and recruitment, it definitely plays a great role, right? Where NLP can be used to identify the candidate by going through the CV, try to do all those NLP activities like named entity extraction and keyword extraction and so on and so forth, and also probably recognitions, right? And then it will probably compare it with a JD and try to come up with a relevance score to identify the best fit candidate. Market intelligence, again, NLP might help by extracting data from social media, right, to help generate some insights for the marketeers. And in healthcare, it can probably help doctors to make informed decisions by going through their semi-structured data, right, like PDFs and all that, and how do we generate insights from that. That probably can be a good use case, the combination of ML and NLP. And some activities, common activities which are listed under NLP would be to kind of go over the stop words. This is to remove the words which do not have any meaning, like if, then, the, and so on and so forth. Stemming and lemmatization, which will take the word to the base form. Tokenization, POS tagging, right? Named entity extraction, identifying relationships, language identification, and word to vector. So this is where we get set to build a language model, right? We convert the text into vectors, and those vectors are fed into machine learning models to try and identify what could be the next word given a set of words, right? Or what could be the next sentence, and what could be the reasoning coming from the data, and so on and so forth. We can also do all the other activities as well, right? Like classification of similar words, clustering, regression, and so on and so forth. So with all that being said, right, let's look at what are the services we have from IBM for free, which can be explored to a great extent, to process natural language, right? The first one is Watson Assistant. If you want to build a chatbot quickly, then this is a GUI-based assistant which is readily available, right? We offer a 30-day trial as well, where you can make use of that trial and try to play around and fit it into whichever environment you are working on, right? And there is also Watson Studio, which kind of is a go-to platform for any data science related activities, where it supports in-house and open source libraries. Watson Natural Language Understanding is pretty much used for sentiment analysis. How do we quickly analyze the sentiment for a given document, right? Watson Machine Learning is used for all the data science related activities under different use cases, right? Like regression, classification, clustering, and so on and so forth. And there is also Watson Personality Traits, which will kind of highlight the personality insights given a specific set of data set, right? We also have tone analyzer, we have speech to text, we have text to speech, right? It is available in specific languages at this point, but if we want to make use of that, and these are all needed pretty much in in the area of natural language processing, right? And also language translator, there is Watson natural language classifier, and so on and so forth. So all this offerings, right, are available for us to kind of download and try it for free, and then see how it works or how it can be plugged in to build a better solution, right? So till now, what we have seen is an overview of what is machine learning, what is natural language processing, what is AI, right? And we have also seen a couple of offerings which can pretty much support, the machine learning and natural language processing and so on and so forth. But where do we, can we, is there a place for us to try? Is there a playground for us to kind of play around and all that, right? So this is where IBM Code Patterns come into play, where we target the developer community here. What we do is we create solutions for different problems under different domain, and we also provide a 360-degree view of the architecture diagram, underlying code, everything. Even the source code is also released right to the open source community. So what it does, right, it provides an empowering experience for the developer. It also has a platform where developers and data scientists and also the beginners, right, can play around, see how it works, see what are the aspects which are involved in different kind of learning that we spoke about, right, and which offering fits in well, and how do we explore that with along with step-by-step instructions. We have all the documentation ready. We have Git repos available. We have, we also release the source code for reusable solutions, right? And we have more than 300 plus odd code patterns across, different technology stacks, right? And they're all open sourced and available at zero cost for download and reuse. And, we also have an option to work with IBM Advocates or become an IBM coder, right? So the reason I'm sharing this is because it is a playground basically, right? You are given a playground. You are given IBM Watson offerings, for a period of 30 days. You have the use cases listed there already, right? All you need to do is log on to that URL and go into the Git repo and gets to see the step-by-step instructions and try to play around yourself, right? And that will help to a great extent in enhancing your learnings as well, right? So this is how the repo looks like. I mean, this is how the landing page of the code patterns repository. As you can see that we have more than 300 plus code patterns. We have so many areas which are already bucketed into different sections. For example, I can select natural language processing, and I see code patterns which are pretty much under natural language processing. Right, I can probably select one, and this is how the repository looks like. It has summary, description, flow diagram, instructions. Right, you click on get the code, and you'll be directed to the Git repository. And this is where you get step-by-step instructions to kind of explore this particular offering along with a use case. Right, it has all the details listed here, and we can get started and just complete all the steps here, and we should be able to understand how to build a chatbot quickly, right? Like this, we have so many other code patterns, right, which talk about NLP, which talks about machine learning, which talks about AI as a solution, right? Can all be explored in this particular site, which is developer.ibm.com/patterns. So with this, I think I have come to the end of my session, where we have covered pretty much the overview along with the Watson offerings and playground for everyone to play around and understand how these offerings work and what exactly is AI, what exactly is NLP, right? To get a first-hand info of the content available along with source code. I'm open to questions if there are any at this point.
Yeah, hi. So we have a question. ML is set to emulate human cognition, but there are certain areas that need human touch and fine human judgment. How will that pan out?
Yes, human touch and human judgment are definitely there, right? The machine will not be able to do everything. Machine can only supplement whatever humans can do, right? Maybe it can help with some bit of automation, like I mentioned, right? Like pattern recognition or identifying the events which are going to happen in the near future, right? With the help of predictions or probably forecast some areas, right? But definitely human touch is needed even after we receive the predicted results, right? We still need to kind of analyze those results and see if that makes sense, see if it is aligned with the business objective, right? And then go ahead and take a call as to how we can fine tune that results. And like I always say, right, it's a iterative process. Keep iterating till we achieve the objective.
Okay, so there's a second question. How would you approach a problem in NLP for other languages like Hindi, which is very easily solved for English?
So for Hindi, I will obviously use a language translator and I'll translate it to English or any other language that I'm comfortable with. And once it is translated to, say, for example, English, right, then all the other steps are straightforward. I'll do all the activities step by step, like, stop words removal, stemming, lemmatization, and also, tokenization, POS tagging, part of speech tagging, right? Once that is done, then I'll see how to best align with what my requirement is. So in your case, the language translator should be strong because it should complete or convert the exact Hindi text into English. If there are some words which are getting missed out, right, then there could be an issue with the accuracy of that model or solution.
Okay, so I would also welcome our other speakers to weigh in their thoughts. Mr. Arora, would you like to weigh in your thoughts?
Sure. Yeah. Sorry, I was muted. Yeah, on the first item, first question, which is there about human touch, and yeah, as already explained, not everything can be done by the machines. But said that, there are sensors which are being developed, which are going to give you a touch sense as well as the smell sense. So I know when those are becoming in use, when they come in use, then probably we will start getting some data from there and start emulating some part of the human brain on the touch and smell part at least. And let's see. But it's AI. It's not human, so not everything can be emulated. And on the second part, yeah, it's each language like Hindi, Chinese, every language is complex other than the English language, and we have to follow the hard and rigorous method to do the lemmatization, finding the stop words of the languages and analyzing. In fact, using a translator from Hindi to English itself is an NLP problem. And to build that translator, you need to first understand the language and be able to process it. So yeah, it's a hard process, but not like it's not NP hard. It can be done. Just needs more time and patience and iterations, as he said.
Yeah, and also, a couple of the offerings from Watson might help, right? It has the conversion, language translator, speech to text, text to speech. All this will aid in building a voice-based NLP solution as well, along with text-based. But again, like it was said, it is a hard problem, but we do have some translators available, which probably does say 60 to 70% of that work. And just 30% again, a human touch and innovation is needed to kind of complete that.